There are no such things as stones. Right. The thing that you need to learn about transmission lines is that, as Edison wanted to show, transmission lines carrying electricity can be dangerous. As we know, they can electrocute you. So we have to be somewhat careful of electricity. As you know, you can get dry arcs of electricity in air. Okay? If you get the large enough voltage, you'll actually get arcing from place to place. And indeed, it was this arcing which has been deemed responsible for some of the Black Saturday fires. Not too far from here, where high winds caused wires to come close enough together that they got an arc across it which set fire to things.
There'd have to be a fair bit of voltage and current in that, because air's an insulator.
Be careful which word you use.
Oh.
Voltage is the critical one. Yes, there is, but in lines with the 330 kilovolt line, 330 kilovolt, 330,000 volt lines, and the 500,000 volt lines, when you walk under them, you can hear them. You can hear the zzz sound going with it, and that's the sound of the current. Yep, and those things will arc over a metre. So if you climb up anywhere near them, you don't have to make contact with them, they'll arc to you.
What about when they run over the top of the caravan park?
Yeah, they're fine, because you notice how tall they are.
Yeah.
There's a reason they're a long way up. That's so that they don't arc. But there's a good reason they say don't drive under them with your mast up and things like that. Yeah.
Like on a rainy day, you can always hear them.
Yep, that's right.
Like some of the energy lost actually goes into sounding.
Yes, absolutely.
So, like, is air an insulator?
Yes.
Because if it was a conductor, it wouldn't be much better.
If it was a conductor, every time you walk past a power point that was on, you get zapped. And you don't, so it's not. But don't forget, conductor and insulator are relative terms, because anything will conduct if you zap it hard enough.
I saw an article, they found something that conducts and insulates like perfectly well. Thank you.
Oh, I haven't seen that. Okay, I'm interested in that. But what you need to avoid doing is getting too close to power lines, because if you do, they can hurt you. They can even kill you. And as one of Tom's close relatives found out when they drove through a power line with a truck, it's a bad idea. So they do have some protective device on these things to help you. The first thing, that is a typical power distribution pole. This one is a higher voltage pole. In towns, you're going to learn about this and you have to know these figures. In towns, you'll have poles which will carry several thousand volts. You'll have poles which will carry household voltage at 240 volts. And then out of town, you're going to have the high voltage lines, which can be anything from 50,000 through to 500,000 volt.
500,000 volts, what was that?
That's those big steel pylon things that march across, you know. And also 330. They're more, yeah, they would be. Along the road like this, there'll be 1,000 volts. Yeah, easily. Now, the first thing you notice is the material that this thing is made of. Wood. Wood is not a great conductor. It will conduct, it's not too bad. And yeah. The other thing you'll notice is that for other reasons now, we're heading towards concrete pylons. And same thing, it's because they don't tend to conduct, which is a good thing. It will protect you. No, well, if it was a conductor, one of the issues that you're going to face is that if it did happen to short onto that and you lean against it, it's not going to do you a lot of good, because you'll end up with the current going through you and into the ground. Right. One of my sons was a great illustration of this. He was standing on a farm gate one day, holding onto an electric fence, and nothing was happening to him. And people thought, oh, the electric fence is on, so they walk up and grabbed it, and they're on the ground. Because he didn't have a potential for it, you know, because he was in the same circuit, he didn't get zapped. But when everyone else grabbed it, they go, ah, that's all. It didn't matter which way around, because he's off the ground. The fence was on a wooden post, it was off the ground, so he's separated from the ground, so there's no path, so he can touch that as much as he wants. If someone walked up and touched him, they got the electric shock, and he went, oh, what's wrong with you?
So good.
So
He would have got some electric shock if somebody would have.
was less. Anyway, so the pole is designed to actually separate us from the current and to be an insulator. The other thing, as I said, is that it's got height on its side, so they're designed to be lifted up out of the general reach of the populace, although not high enough. These days, in modern places, they will often bury them for the same reason as the separation.
The transmission lines, you said the biggest ones are like 500,000 volts. At the actual power station, which they split it up, what's the highest voltage you can get?
That's what they're producing at, around about that.
Oh.
Now, what you do have and what you're saying is you notice that there is a wire down here. That's an earth wire. And what it's designed to do is if something goes terribly wrong and you do get shorting, that wire will carry the current into the ground. Yeah, you do. It's legal. You need to have an earth in your house, and it's actually a big metal spike about this big that is actually buried deeper into the ground. Pardon? Third pin in it. That's exactly right. And this acts in the same way. So if you get a short, it will take the current directly into the ground. That doesn't make it totally safe. I was in Walgett in my lab. We had the labs, and there was a fence, and there was the street, and there was a pole directly outside. And it had created a big short, it had a transformer on it, it had earthed. No one knew until someone walking their dog came along, the dog relieved itself on the pole and got a nasty shock for it.
Did it? Ah.
The dog got a bit... Now apparently normally if you pee on an electrified fence, it probably won't hurt you because the stream is not continuous. But if you pee and you happen to be, some of it runs down and you happen to stand in it or something, that's going to make a stream.
Really need to go then.
Okay. Anyway, what it did do, they found out that as the ground started smoking and steaming, that did mean there was a short going on and a serious problem. So even though it does alleviate some of the problems, it doesn't make it perfectly safe. Right. On here, you'll also notice that there is a thing called a shield conductor. And there's an earth from the shield conductor. That is universal. If you look at all your power line and supply lines, every single one of them will have a top line like that. That line is there for lightning strikes. So if it gets struck by lightning, that line is designed to carry that current and to drop it down. Why do you need lightning strike protection on these things? It's not just the overloaded circuit. Why are they likely to be hit? They're big they're big lightning rods. They've got current running through them. They're tall. They're above the surrounding structures, so they've got a likelihood of being hit.
Like, you know how you have the ones that just have 3 lines? The middle lines actually.
No, there's always a top line if you look.
There's usually like ones with just 3 lines.
They might be. They're the very old-fashioned ones. I'm not sure about those, to be honest. Now, so that's 2 things that you've got going with it. The third thing, guys, is the fact that you can see these bits and pieces hanging off. The wires aren't connected directly onto the post. So what are they there for? Those bits and those. They're insulators. They actually separate the wire. You notice the wires pass well below the wooden crossbar and are held in place by insulators. You notice there's a stack of insulators there, but these ones only have small insulators. They're taller, they're lower. They're high voltage, they're lower voltage. That's the shield conductor, which is there so that if it gets struck by lightning, it carries the current of the lightning strike. And you can see that there's an earth that goes all the way down the pole there that goes to it.
When you see a telegraph pole, it's always got that plastic tube coming out now.
Yeah, that's the earth. Now.
So you don't grab that during a lightning storm?
No.
So where's the telephone?
Now, in this, telephone lines are a separate line. They're also carried on the poles. It might be the third wire you're talking about, actually.
So
and they are, the difference between a household supply voltage and the telephone line is something like 235 volts.
So how far, these in the ground lines like that, how far down are they?
About a metre.
Only?
Metre and a half. Oh, they don't do high voltage. underground, they only do the 1,000 volts and whatnot. That's for the in-town distribution, not for the transportation around the place. Now this is a...
Because that's like American would be one that you see on like the way to Albury or something.
You do see these around. This is actually from Australia. Same job. I'll go to those in a minute. Now, again, you notice these little devices here. What's their job? No? What's that?
Separating the wire.
Separators. They're separators, spreaders. They keep the wires apart so they don't come up and shorten each other. You'll notice the stacks of insulation cones there, and they do exactly the same job as insulators in the other one. Again, there's a shield wire there. You can't see terribly well. You see the line running down that.
How do the
Now,
US ones work if they don't have an earth on like the PowerPoint button? Because the US ones are usually just too strong.
not everything in Australia is earthed either.
Yeah, but like...
It works. It's just an active and a passive line,
Yeah.
and there's no, if it happens to short, it won't have a feed out. It'll be an active short, and when you touch it, you'll get very zapped.
In America.
But don't forget, we now have those safety kill switches, which are almost instantaneously. Now, these are the ceramic insulator cups, right? Look at the shape of them. You'll notice what they hook at the top. It's all made of ceramics, which will not conduct electricity.
Well, it will.
Well, it had to be a massive volts. They actually almost, no, it had to be way more than that for these things, yeah. And they can form in chains. These are different types of them. And you'll notice that the shape is quite specific, because what it's designed to do is if you just had a cylinder like that, and then the wire connected on the bottom of it through it, there isn't far for the current to travel if something goes wrong, right? But with a cup one, the wire, the electricity actually has to travel around the outside of it, up around there and around there to get to the top. So there's a longer path for the current to travel through, which makes it safer. No, it's simply to do with path length. That's what it is.
What if it like had like a massive downpour?
These things can, these things can go wrong because they can get water and gunk in them. You know, birds can try and build nests in them and that sort of thing. And sometimes they will heat up and catch fire. But to try and prevent that sort of stuff going on, this is what they do with them. They chain them. They make chains of insulators. And the more of them they have means that the larger the voltage is going to be carried in that line. And so these are just lots of those individual cups chained together. They just have a little hook on the end of them. They just hook in together, and they hook, they hook in a chain, and then the wire goes down beneath them.
How much voltage does that those?
That's this is a substation, and we talk about that in the next part of the topic. Well, you have a substation will have lines out to various places for a start. So you might have 4 output lines, and a town might get a supply from 3 different substations. So it might need supply from this one, so it'll be switched on, the other one will be switched off for that particular line. So it's like power points around a house. It's just changing which circuit's running, and each of them have to supply at the right voltage. Yep.
You said the big transmission lines carry really high voltages.
Yep.
Low currents. Even if the voltage is really super high, but the current is like really low, can it still do it?
Yeah. You get.
So you get like 1 amp. Yeah, 1 amp is just like 1,000,000 volts.
Yeah, it's possible to have high voltage, low current.
Well, what
Def-
would that do to you?
But can you survive?
One amp?
Yeah, I mean, if you go near a half.
That's James Bay. It's a music video. Which is on Spotify.
Okay, there you go. Let me show you quickly what can happen.
Oh, wow. Yes.
Holy.
It's like a red draw, like a...
I don't know.
Electric fail, explosion, fire infection. Everything.
There it is.
One time, Tom.
What happened? How did that happen?
That happens from time to time. There's actually not a failure there. They've done electrical switching, and obviously it's still got current running through there. And yep, the thing about it. Actually, what I'm going to do is I'm going to take it off because it's all right. Yep.
But why does it
How much
keep
wasted there?
5 zaps.
Holy.
why does it keep
It's like a
going
nitro
up?
surface effect.
Well, it ionises the air, and that's the path it makes through there. Yeah, that's one. That one went catastrophically wrong. So did that one.
Oh,
Well then.
That's actually that's actually where a transformer
oh.
has gone.
Like that.
That is bad. That's when insulator's failing.
Feel like an iron.
So they just got ringing sound. It's just like.
I'll put this on YouTube.
That's right. That's what Trump's getting around. Two people like punching on it instead of like going, oh no, that's like, it's like.
There's another failure, obviously.
The lens going top 10.
JJ
Piles
Abrams.
of
It's
lists.
JJ Abrams.
No, I think that'll be number 8.
Why is Doc Brown here?
Who compiles a
Really,
list
sir?
of the top 10?
We're mature, sir.
No, I think this one should be number 8.
No, that's ridiculous. You put the.
That's the substation going up.
And one of them. Oh, number 2. You're ridiculous.
Oh,
So when it fails fairly catastrophically at times.
That's the one for this one.
That's the one you saw earlier.
It's weird. So how much coal is being wasted right there?
5.
who cares? It's awesome.
That's a bit of a cheat. That's actually a demonstration. Yeah, that's a demonstration of a failure.
Yeah, drop that in the comments there. Say this is bullshit. Why is Doc Brown there? I love Doc Brown. That's the second time he's been shown.
21,000 gigawatts. 21,000 gigawatts.
Okay. What's that? I don't know what that's. Okay, so that's the essential parts of the power system you have to know about for safety, for insulating us from what goes on. Okay, and